Hello everyone. In this video, I'm gonna discuss the questions number 21 to 30. So the whole video is about the paper 1-3 of CAIE AS and A levels May-June 2023. So the question number 21. Graph 1 shows the variation with time of displacement at a fixed distance along a progressive wave. Graph 2 represents the same wave and shows the variation with distance of displacement at an instant of time. So you have displacement time graph and displacement distance graph. What is the speed of the wave? So you need to find out the speed of the corresponding wave. You know that the speed of a wave can be calculated using the formula V is equal to F lambda. So this is a wave equation and F stands for the frequency and lambda is the wavelength, right? Frequency is 1 over t, so it would be lambda over t. So if you have the lambda and the time period, you can calculate the speed of that wave. So you have these graphs. So from this graph, the first one, displacement time graph, the time taken for one wave is what we call the time period. So from the graph 1, you can calculate the time period as 0.40 seconds, right? And from this graph 2, displacement distance graph, the distance traveled during one wave is what we call the wavelength lambda. So from this graph you can find out that lambda is equal to 120 centimeter. So here you can substitute, so it will be 120 centimeter divided by the time is 0.40 seconds. So do the calculation and you may be finding the value as 300 centimeter per second. So for the question number 21, option D is the correct answer. Question number 22. A vehicle moves with constant velocity along a road directly towards an observer. The observed frequency of the sound from the vehicle changes as the vehicle moves past the observer. Which phenomena explains the change in frequency? So the change in frequency is explained by the phenomenon called Doppler effect. So it is the change in the observed wave frequency when a source moves with speed. So the answer for this question is option D. Question number 23. An electromagnetic wave has a wavelength of 2.1 centimeter in a vacuum. Which region of the electromagnetic spectrum contains this wave? In order to answer this question, you must be knowing the wavelength regions of this electromagnetic waves. We know that there are 7 types of electromagnetic waves and the corresponding regions. So the regions are like this. Radio waves will be from the wavelength of greater than 1 millimeter. The microwaves will be from 1 millimeter to 1 meter wavelength region. So you maybe find out that these two are overlapping to each other, and infrared waves are 700 nanometers to 1 millimeter and 400 to 700 nanometers will be for the visible light. Likewise, the wavelength will be decreasing from radio waves to gamma rays, right? So here the wavelength is given as 2.1 centimeter, which means that the range is here, the range of microwaves 1 millimeter to 1 meter. So millimeter range and the centimeter range will be coming under the region of microwaves. Here the option B is the microwave. So the answer for this question number 23 is option B. Question number 24. A source of plain polarized light is observed through 2 polarizing filters. The filters are positioned so that the source appears at its brightest. So these filters are positioned to have the brightest image, or the sources at the brightest. Okay, one of the filter is then rotated clockwise and the other is rotated anti-clockwise through the same angle. How does the source appears when both filters have been rotated 90 degree and 180 degree from their initial positions? So in this question you must be knowing that it is having a source of polarized light, but we don't know what type of polarization. It is vertically polarized or horizontally polarized. That's why it is given this point. The filters are positioned such that the sources appear at its brightest. So brightest, which means that all this polarized light is passing through the two filters, okay, which is having the transmission axis vertical. So the polarizing filters are having the vertical polarization, which means that the polarized light is vertically polarized, right? So these are vertically polarized, so the vertical axis must be like this. So the polarized light will be passing through this first filter and then through the second filter, right? Then we need to find out how the brightness would be if it is rotated 90 degree, right? So initially it is having a position here like this, and then the transmission axis is rotated 90 degree anti-clockwise for the first filter. I'm just discussing the first filter because it would be easier, okay? So if it is positioned like this, none of this wave will be passing through this, right? Through this region. Since it is vertically polarized, all the waves that is coming after passing through the first filter will be vertically polarized, and then it is passing through the vertically polarized second filter, right? But here in this 90 degree case, it is in this way, the transmission axis in this way, so no polarized light will be passing from this first filter itself. So obviously there is no light passing through the second filter as well. So the observer will be having a visualization of the darkest source, right? So it will be either option C or D. So it would be against the C and D options. So we can check for this 180 degree as well. So these are vertically polarized light, and here it is initially in this direction is the transmission axis. Now it is in this direction, okay? So there is an opening in this way now. So all the lights will be passing through it, right, from this first filter. Because it is now vertically polarized. Previously it was in this direction, but now it's in the opposite direction. The result would be the same, because all the vertically polarized light will be passing through the first filter and it will reach the second filter. Now let's discuss. The second filter is rotated clockwise, and it would be having the same polarization as the initial position, right? As in the initial case, it will be having the vertical polarization. So the light rays will be passing through the second filter as well. So you will be getting the source at its brightest. So it will be option C. Let's check the polarization of light in 3D view. This is the polarized light, okay? The source of polarized light is here, and this is the first filter. So I'm just changing this angle of the polarizer. So now it is in 90 degree. So is there any light is passing through this first filter? No, right? Because it is at an angle of 90 degree, it is rotated. Then I'm again increasing it, and now it is in 180 degree. Right, so it's again in the same position but in the inverted case, but the effect would be the same, and all the light would be passing through the first filter. Okay, I think now it's clear, and the correct option is option C. Question number 25. The diagram shows a string stretched between two fixed points x and y. There is a stationary wave on the string. The solid curve shows the string at the position of maximum displacement at time t0. The dashed curve shows the other position of maximum displacement. The straight central dashed line shows the mean position of the string. The point S on the string is directly above point P, so this position, and the point T on the string is directly below point Q. So this position. Which statement is correct? So you need to check each statement. So let's check the first one. A short time after t0, point R on the string will be replaced. So here it is the point R. Okay, so in a stationary wave we have antinodes and nodes. So the antinodes are those which are having the maximum displacement. So these points S and T are at the antinode position, but the point R is in node. Node, which means that it doesn't have any displacement. So whenever there is a stationary wave on this string, this point will stay the same. So there is no change in this position of R. So this first statement is wrong. Then let's check the next option B. A short time after T0, positions S and T on the string move in the opposite direction. Right, because this position S is at the maximum displacement, right? Then after some time it will be moving to the mean position and then to the other maximum position, right? So this position T will be moving towards the mean position and then to the other maxima, right? So after some time it will be moving to the opposite direction anyway, which means that option B is correct. So our correct answer is option B for this question number 25. You can check the other options as well. Option C is that the distance between P and Q is one wavelength. So distance between the P and Q, this distance is one wavelength. No, it's not correct because it's having half the crest and half the trough, which means that it is having the half wavelength, not the full wavelength, right? Then option D, two moving points on the string that are equal distances from R vibrate in phase. So let's check 2 points. Okay, the first point I'm just taking this point Q, and another one of equidistance here, point A, I'm just considering. Okay, so if this point is moving, it would be either in this direction or this direction. I'm just taking in this way. Okay, then this point A will be moving in the opposite direction. So these two are not having the same phase, so these are not in phase. So option D is also wrong. Question number 26. The variation with a distance x of the intensity along a stationary sound wave in air is shown. The speed of sound in air is 340 meter per second. What is the frequency of the sound wave? Okay. So in this case, you can use the wave equation. V is equal to F lambda. So F is what you need to calculate, which is equal to V divided by lambda, right? So the V value, the speed is already given, but you need to find out the lambda. But here what you have is that intensity variation along this distance, right? And you know that the intensity is proportional to the square of the amplitude, and the amplitude is the displacement from its mean position. The maximum displacement from its mean position is what we call the amplitude. So let's draw the displacement distance graph. Okay, so from that graph you can find out the lambda value as you have did in the previous question. It's having a maximum intensity first, and then zero intensity, then maximum intensity, then zero intensity, maximum intensity, and so on, right? So here this y direction is representing the displacement. Okay, so displacement from its mean position, and here on the x-axis it is the distance, x in centimeter. So here it is the origin 0. Okay, it's taken as 0 here, and in the first case the intensity is maxima, so the displacement also be maxima since it is proportional, right, the amplitude. So at this position, then at 5 centimeter the intensity is 0. So if that intensity is 0, that amplitude also be 0, which means that the displacement is 0, right? So this is the position of minimum amplitude, or 0 amplitude, 0 displacement. Then in the next case, at 10 centimeter, it's having the maximum intensity. Then it is a sound wave, so it will be a compression and rarefaction, and it must be in the opposite direction. Then you must be wondering why it is having a positive intensity, because even if the amplitude, the displacement is negative, when you're taking the square of it, the value, you'll be getting a positive intensity, right? That's why you're getting a positive intensity here, but actually the displacement will be in the opposite direction. So at this maximum displacement, the distance is 10 centimeter, okay? And then it is having a zero intensity or zero amplitude at 15 centimeter. Then the next point, the maximum intensity would be, here it is 5, 5, 5, then just add 5, so it will be 20 centimeter, right? So the distance is 20 centimeter now. So this is how a full wave in this graph is like, okay? So here the crest, the full trough and the half crest, which means that this distance is actually representing the wavelength lambda, which is equal to 20 centimeters. So now you have the wavelength and just substitute in this formula. F is equal to 340 divided by 20 times 10 to the power minus 2, since it is in centimeter. So please just do the calculation and just find out the value, and that value would be 1700 hertz. Okay, so for the question number 26, the option A is the correct answer. Then the question number 27. An experiment is set up to demonstrate the diffraction of water waves in a ripple tank. The waves pass through a gap of width W and some diffraction of the waves is observed. The wavelength of the waves is now doubled. What is the new gap width needed to cause the same amount of diffraction as before? So here, in the case of diffraction, there is a wave length for each water wave, right? So let's consider this first figure. Here, this distance between two wavefronts is actually what we call the wavelength, right? So it's having a wavelength which is less than this gap width. This is the gap width. So in this case, gap width is really greater than this wavelength. So how it would be appearing after passing through this gap width? There is a diffraction of course happening, but it is of really unnoticeable amount, really less, right? Only a small fraction of diffraction is observable. So as you are decreasing the wavelength, the diffraction amount is increasing, and when it is maximum, when this wavelength is approximately equal to this gap size, the diffraction amount is maximum. So in this case also, there is a particular wavelength for this water wave, and there is a particular amount of diffraction happening. So from this case, you might be knowing that when this wavelength is approximately the same value as the gap width, the diffraction amount would be stays the same, right? So you may calculate that, or you may find out that the wavelength is proportional to the gap width W. So here in this case, the wavelength of the wave is doubled. So it is 2 lambda. So the gap width also must be doubled to have the same amount of diffraction, right? So the option C is the correct answer for this question number 27. Question number 28. Two coherent electromagnetic waves are traveling in a vacuum. The two waves meet at a point. At this point, the two waves have different intensities. Which statement about the waves is not correct? So here it is given two hints. One is coherent waves, and the other one is it is having different intensities. So here, two sources are coherent when they emit waves that have a constant phase difference, which means that the option A is correct, right? So this one is the correct option. And then when it is having the constant phase difference, it will be having only if it is having same frequency and or wavelength, which means that the same would be the speed as well. So option C and D is also wrong in this case. So option B is the correct answer. And you may find out in this way also. It is having different intensity, and the intensity is proportional to the amplitude square, right? So if it is having different density, the amplitude also be different. So they have the same amplitude at that point is wrong. So option B is the answer for this question number 28. Then the question number 29. A parallel beam of light of wavelength 600 nanometer is incident normally on a diffraction grating. So here it is a case of diffraction grating. The distance between adjacent slits in the grating is 2.0 times 10 to the power minus 6 meter. A screen is placed parallel to the grating at a distance of 1.50 meter from the grating. Third order diffraction maxima are observed at the two ends of the screen as shown. What is the distance between the two ends of the screen? So here you need to find out this whole distance, right? So this whole distance is what you need to find out. And what you have is that lambda value, which is equal to 600 nanometer, that is 10 to the power minus 9 meter, and the distance between the adjacent slits. So the d value, which is 2.0 times 10 to the power minus 6 meter, and the distance here, this distance is 1.50 meter, and you are considering the third order. So the number of order is 3. So the formula that you may use is this one. N lambda is equal to d sine theta. So n is here, lambda, d, all you know except this theta. Theta is the angle between the center of maxima to the order of maxima that you are taking, which means that this angle. So you need to find out this angle first, and from this angle and the triangle you can find out this length first. And if you know this length, just multiply it by 2 and you will be getting the whole length. Okay, so here sine theta is equal to n lambda divided by d. So please substitute 3 times 600 multiplied by 10 to the power minus 9 divided by 2 times 10 to the power minus 6. The value would be 0.9. So theta value would be sine inverse of this 0.9, which is equal to 64.158. Okay, so now you have this theta and this length is already given, 1.50 meter, right? So if you have this value, just use this tan theta formula, which is equal to the opposite side. So let's take this as A. So opposite divided by the adjacent, which is 1.50. Okay, so just rearrange this, which is equal to 1.5 times tan of the theta value, which is 64.158. So the value would be 3.09 or 3.1. Okay, let's take this as 3.1 meter. So now you have this length. Just need to multiply it with 2, which is equal to 6.2 meter. So the answer would be option D. Question number 30. A metal wire is connected between the terminals of a cell so that there is a current in the wire. Which statement is correct? So here there is a cell, okay, which is having positive and negative terminal, and there is a metal wire connected. Okay, so here it is a positive and negative, and in the case of metal, the charge carriers are electrons. Okay, negatively charged electrons are the charge carriers. So here, suppose there is an electron here on this negative terminal. It is having a repulsion because negative and negative are the same charges, like charges will repel. So it will be moved from this negative terminal to the positive terminal as the opposite charges will attract. So this is a statement, right? So here which statement is agreeing to this? Here you may find out like this: negatively charged nuclei is wrong and positively charged electrons is wrong. And positively charged nuclei is moving from the positive terminal to the negative terminal is wrong, since the charge carriers in the case of metal wire is electrons, which is negatively charged, which means that option A is the correct answer for this question number 30. So by this, I have finished the questions from 21 to 30. In the coming part, I'm going to discuss the rest of these questions in this paper. Thank you.